Finding the area using definite integration. So one of the application of integration is to find the area under the curve, and that area is said to be the integral of the function of x dx, or a is equal to the integral of y dx. But where is this formula come from? It's actually come from the idea of these. Let's try to look at this curve. So let's say that this curve is or y is equal to f of x, and then the area that we're looking for, the boundary, is from number a to number b. So basically here there should be a boundary from a to b, and then from a to b. Okay, now in here the a is the actual area. So what it does is that it tries to divide this one. Let's say we divide this into these two equal parts. Okay, if we divide this into two equal parts, I said equal, hopefully that is equal. So we have here, for example, this we can divide this into a rectangle like this, right? Wherein you have there now, for example, area 1 and area 2. So, but how do we get that area of that rectangle? That one is actually this length, okay? This length, let's say that is equal to delta x, and then times this one. So what is this height? That is actually the value of your y at this point. Okay, so therefore that's going to be delta x times that y. Okay, so delta x times y. All right, or let me call it as y sub 1. And then this one is also delta x then y sub 2 plus delta x times y sub 2, that is y sub 1. Okay, now what will happen if instead of dividing by 2 we divide by 4? So I have here divided by 4, divide by 4. So now we have this region, these rectangles, and as you can see, the approximated area is almost closer. Okay, the area approximated is almost closer to the actual area under the curve. Okay, now how do we get that area that is actually this delta x, that small x, times this one, times y sub 1, delta x times y sub 2, delta x times y sub 3, delta x times y sub 4. So basically guys, you're gonna add each area. Area 1 is equal to delta x times y1, delta x times y2, okay, and so forth and so on. However, this one is still not accurate, because if you zoom it, you can still actually, this portion is still empty. So what is the best way in order for you to approximate the area? What we can do is divide that into very, very thin. Take a look. This is very thin rectangles, wherein this one here is your delta x, okay, and then this one here is your delta, is your y. All right, let's say y sub I. So you have this region. Okay, so basically that is small area, let's say that delta of that area, delta, because that's a small area only. Okay, that delta area is equal to delta x times y. Please take a look of this. If I rewrite this one will appear like delta a over delta x is equal to y. Now, if the limit, okay, of this one is approaching 0, meaning if the delta x becomes very, very small, okay, if you keep on dividing this into very small pieces, make this one the delta x approaching 0, then the limit of delta x approaches to 0 of this one will be equal to your y, this one, okay, will be equal to this, correct? Again, maybe it's confusing there, that part. But what am I trying to say, my dear, is that, okay, let me go back to this one. Maybe it's not that clear. We're approximating the area, okay, and we can take the area of each one of these, and let's say that this one is delta x, then this one is your y sub I. Okay, now, so basically you have there delta of your area, or I will use this symbol, delta of your area is equal to the delta of the x times the y. Why is that so? Because this is the area is length times the width, right? So this is the width, that is the length. So therefore from here we can say that the delta a over delta x is equal to your y. Okay, now if you take for example the limit of this, as your delta x is approaching 0, okay, this one now, remember this is the definition of the derivative. So this one will be derivative of that area with respect to your x will be equal to your y. Okay? Now, therefore, it will give us that our dA is equal to y dx. And then our a is equal to the integral of y dx from a to b. Okay, this is now the formula that we actually want. All right? Okay, so basically you don't need to perfectly know the derivation of this, but that's actually the idea behind it is that divide it into small rectangles and take the area of each and take the sum.